Hi everyone. So this video is part 2 for acceleration. In last video, I talked about the definition for acceleration, the units of acceleration, and I kind of gave you an idea of what we mean by acceleration. We got this idea that acceleration is denoted by a small a with an arrow on the top and is change in velocity over some change of time and during a during a period of time. Delta V is essentially V2 minus V1 and delta T is T2 minus T1. What it means is that, for example, if I go with 10 miles per hour for my V1, then I change my speed to, let's say, 30 miles per hour, and I call this my V2, the second velocity, then the change in velocity is 20 miles per hour, as you can see. So it's 30 minus 10, and that gives me 20. So now if this change in velocity happens, let's say, in half an hour, then this becomes half an hour. This T2 minus T1 becomes 0.5 hours. Make sense? So in this case, acceleration becomes 30 minus 10 over 0.5 hours. That gives me 20 over 0.5. That gives me 40 miles per hour squared. And we learned about this miles per hour squared or meters per second squared. That was the units of acceleration in the previous video. Because most of the time we set our zero, initially we set our time to be 0, this becomes always 0, and therefore we always pretty much what we have is always this. So this is exactly the amount of time that's passed. For example, here is 0.5 or like half an hour. And then this is V2 minus V1, the change in velocity. And I also told you that acceleration is change in velocity, not velocity by itself. Therefore, whenever you are having a motion, it doesn't mean that you're necessarily having an accelerating motion. If there is a change in your velocity, if you're pressing either on your gas pedal or your brake pedal, then for sure you are changing your velocity, therefore you're having acceleration. Otherwise, if your car is on cruise control set at some specific velocity and it's not changing and that velocity is constant, then there is 0 for its change for velocity, hence the acceleration is dead zero. In this video, what I would like to talk about is basically doing some examples of, of A equals V2 minus V1 over T for you. Do some examples of this. And also I want to tell you that because change in velocity is a vector quantity, and the vector quantity is divided by some number, let's say here half an hour, it could be 15 minutes, it could be like 4 seconds or whatever else, because this denominator is only a number, you end up with a vector in the end. So let's just talk about why acceleration is actually a vector, and then I'll do some examples for problems that are having that accelerating motion in them. Okay, so if you recall, I told you acceleration is change in velocity over change in time. Suppose your initial velocity is, let's say, 20 miles per hour. Or let's just do SI system. Meters per second. Now you change your velocity and you change it to, let's say, 30 meters per second. So because it's 30, it's bigger than 20, the length of your velocity vector has to be greater, and the direction of the velocity tells you towards which direction you are moving. For example, if you're driving a car with 20 meters per hour and 20 meters per second, if this is the direction for the velocity arrow, then this means that you are heading this way. And then you're going with 30 meters per second. So you're changing your velocity. Change in velocity means acceleration. Now, the change in velocity vector is going to be 30 minus 20. So it's a 10 meters per second. Let's make it a little bit bigger. Half of this length, right? Because this is 20, so half of it would be 10 meters per second. And this is the vector for delta V. So as you can see, I have this 10 meters per second, and I can have this change in, let's say, 5 seconds, right? So then my acceleration would be the change, the 10 meters per second, over the 5 second, which gives me 10 over 5, gives me 2 meters per second squared, which is my acceleration. So 2 meters per second squared. So I'm essentially, what I'm doing is that I'm dividing this 10 meters per second delta V into 5 sections, and every single one of them is 2, and that is basically my acceleration. So acceleration is a 2 meters per second squared vector, right? So basically this 10 meters per second vector divided by some number, now it actually shrank to like 2 rather than 10. And that becomes the vector for your acceleration. Now, suppose this change in velocity happens in change in velocity that is like 10 meters per second. The same change in velocity happens in half a second. So acceleration would be 10 over half a second, which gives you what? Which gives you 20 meters per second squared. So now the vector for your acceleration is double the vector for lengthwise, double the vector for your velocity. If you are having your velocity vector this big, this long, then your acceleration is 20 meters per second squared. It's going to be double the size in length because that was 10. This is now 20. Why? Because it was divided by 0.5. So this becomes the vector the vector that represents acceleration, which is 20 meters per second squared. So say see the first scenario I ended up with 2 meters per second squared. So my acceleration vector actually got smaller than the delta V because it was divided by 5, a bigger number. Now it's divided by 0.5, which gives rise to a bigger number compared to delta V. Okay? And makes the acceleration vector bigger. So therefore, we see that because we are dividing a vector by only a number, see, it's 5. It's just a number, 5 seconds. There is no direction to it. 0.5 seconds. There is no direction to this. Because we are basically dividing a vector by a number, we are either shrinking it down to some smaller vector, in this case, or basically elongating it and expanding it to a bigger number like 20 compared to 10 meters per second. Therefore, this is actually a vector quantity. And in the previous video, I worked out the units for it. So here is meters per second. Here is just seconds. This is a complex fraction. So I give this a denominator of 1. Meters times 1 gives me meters. Seconds times seconds gives me seconds squared, right? Okay, so in the in the next video, what I'm going to be talking about is I'm going to be talking about free fall. And because due to gravity and Earth, we are every object that's dropped down, it goes towards the center of our Earth. And in that video, I'm going to be talking about free fall